Hi guys. In this session, I'll show you the preparation process for exporting to Unreal, along with how to set up your existing rigging as a Metahuman setup in Unreal. First, if you haven't created an LOD group before, we'll start by creating one using the MetahumanSet tool. Once the LOD group is set up, LODs will automatically switch depending on the camera distance. However, this feature isn't that important in Maya for now, so we'll turn off all LODs except for LOD 0. Let's do the same for the head. Leave only LOD 0 and turn off the rest. Now, even if you move the head joint like this, the control board doesn't follow. So set Face GUI Follow Head to 1, and then click the Align Facial Board button. After that, slightly move the facial board control, and the control board should align properly. Then, we'll move the created head LOD group and body LOD group to the outermost level for now. In the old legacy method, the head joint and body joint were originally separated, so exporting them individually wasn't an issue. But that's not the case with the newest method. Now there's only one root, and the body and head are merged under it. So should the user manually restructure everything into the necessary export formats like this and edit it manually before exporting? Build a structure like this on their own? That sounds way too inconvenient, doesn't it? That's why we've prepared a powerful new tool for you. It's called the Rig Manager. In the Manage Hierarchy Joint tab of Rig Manager, you can customize the joint hierarchy in any way you like. Let's start by clicking on the menu to load a preset configuration file. This preset JSON file is located in your Documents folder under tunaRig, Tools, JSON Files. Once you load it, you'll see 3 new hierarchy sets appear. Let's start by looking at the Body Export set. This hierarchy closely resembles what you see in the outliner, but it's specifically structured for the body only. Here, the rig group and the root joint are at the top level, but in the actual outliner, the root joint is parented under the rig group. Now, what happens if I select the full hierarchy in the outliner, including the rig group, and then apply this body export set? Something has changed. You can see that the root joint has moved to the very top level in the outliner. If we look more closely, we can see that the root joint now contains only the body joints. This means that the facial joints and related parts are still within the original rig group. If I temporarily hide the rig group, you'll see that the root joint now only contains the body joints and has been moved to the outermost hierarchy level. This setup is perfect for export. From here, just open the game exporter. Then, select both the body LOD group and the root joint, making sure to select the entire hierarchy. Switch to Export Selection Mode, uncheck Input Connections and Embed Media. Set the export path, and simply enter the name you want for the exported FBX file. Now go ahead and export. Next, just like we did for the body, we'll export the head as well. Here, the head hierarchy is already fully set up. Inside the rig group, there are body joints that won't be used for export, and inside the root joint, you'll find the head joints that will be used for export. To apply this setup, you need to select all the items registered in Rig Manager from the outliner. Make sure to select all of them as a hierarchy. Then select the head export set and click Apply. You should see that the hierarchy has changed. As expected, the root joint now contains only the joints related to the head. Now, just like before, select both the head LOD group and the root joint, including their entire hierarchy. Rename the file to something appropriate for the head, and then export again. With that, the export is complete. Now let's select both the rig group and the root joint and revert everything back to the original setup. At this point, you might be wondering how to register your own sets in Rig Manager, right? Let me show you an example of how to register a new set. First, I'll temporarily unparent these two joints. Then I'll pull the root joint out to the top level. And I'll move those two joints back into the joint group. Now, the new set I want to register will represent exactly this current state. The parent group of the two joints is the joint group, but you shouldn't stop there. Just like the existing sets, it's best to include the top-level group as well. In this case, that's the rig group, so you should select that too. With everything selected like this, click Register Rig Set and enter a name for your new set. Then, you'll be able to see your newly registered set added to the list. Now, let's do a test by applying this Accept ARM set. Select both the root joint and the rig group, including their full hierarchy, and apply it. You'll see that the hierarchy is applied exactly as we set it up earlier. All right, now I'll revert everything back to its original state. Next, let's move to the engine and import the head and body we exported earlier. Please copy the Unreal uasset folder located inside the tunaRig folder in your documents into the content folder of your own Unreal project. In my case, I've placed all those assets inside a folder named Tools. If you don't see the assets, try restarting the engine. I've also created a folder called Cartoon inside the Metahuman folder, and I'll be managing the character from there. Let's start by importing the body. The first thing you need to configure is the skeleton. If your joint structure differs from the original Metahuman base skeleton, make sure to set the skeleton to None. However, if your structure matches the original Metahuman base skeleton exactly, you can assign that skeleton directly. And if multiple versions of the Metahuman base skeleton appear, make sure to select the one located in the Common folder inside the Metahuman folder. Also, I will not be generating materials or textures. Please feel free to handle that part according to your own preferences. As you can see, both datasets have been imported cleanly. Since I don't need a physics asset, I'll go ahead and delete it as well. Let's open the skeletal mesh briefly. Yes, the joints have been imported correctly. I'll save the asset now. You should be able to see that the body mesh has a total of 4 LODs imported properly. In Maya, if you use LOD groups when exporting, you can bring them in accurately like this. Please keep that in mind. Now, let's import the head. Make sure to assign face archetype as the skeleton for the head. As with the body, the skeleton structure must not change. And even if duplicate names appear, you must select the face archetype inside the Common folder of the Metahuman directory. Since the head uses morph targets like blend shape data, make sure to enable morph target import during the process. Again, I won't be generating any materials or textures. And as before, I don't need the physics asset, so I'll delete that as well. Sometimes, when checking the skeleton information of the currently imported skeletal mesh, you may see a prompt saying the skeleton has changed and needs to be saved again. Unless you intentionally modified the skeleton or added new blend shape curve data, do not save any changes to the default face archetype skeleton. It must remain untouched. As for the body, there seem to be no changes. Great. Now I'll take an existing blueprint from another Metahuman and use it as the dedicated character blueprint for this cartoon version. Move the blueprint into the folder for our character. and remove all the skeletal meshes that are currently assigned to it. I'll replace both the body and head meshes with our cartoon character versions. You might not see any immediate response after replacing them, don't worry. Just go ahead and swap them first. If the replacement doesn't seem to work properly, try compiling the blueprint, then close and reopen it. Let's try swapping the head again. It looks like the replacement worked, so I'll compile and reopen the blueprint once more to be sure. The groom data is a complete mess, so I'll clean all that up first. To clear a skeletal mesh, assign any mesh temporarily, then click the arrow button that appears on the right side. This usually also removes the associated materials automatically. Use this method to clear each one. Once you're done, you might see the body appear squashed. That's because the old materials are still applied. If you clear the materials completely, this issue will go away. It's best to leave everything in a clean state like this, with no materials applied at all. Now, since we had already assigned material IDs in Maya before exporting, the material slots should be properly separated by part. Later on, you can simply assign your own custom materials to each of those slots. Some of you who have used earlier versions may be familiar with the Metahuman AutoSet tool. However, in this newest workflow we're using now, that tool is no longer needed. Once DNA is embedded into the body, there's no longer any need to create separate pose assets, RBF pose animations, or character-specific body post animation blueprints. If your engine is Unreal 5.6 or higher, and you've been following the newest method, you should stop using the old Metahuman AutoSet. Instead, use Metahuman AutoSet Newest. Even from the UI alone, you'll notice that it looks slightly different. In the newest tool, the input fields for the character name and pose animation are gone, and a new field for specifying the body DNA path has been added. This means you no longer need to create separate pose animations just to correct the body. In older versions, you probably remember clicking the Bake All UE RBF Poses button to generate and bake all poses into animations, right? Well, in the newest mode, there's no need for that anymore. All the necessary information is cleanly saved inside the DNA, so as long as your DNA is saved and loaded properly, that's all you need. Now let's go over how to use Metahuman AutoSet Newest. At this point, if you click the Check Template button, some of you may see a message saying the template was found, while others might see nothing at all. This can be confirmed by checking the common folder inside the Metahuman directory. If even a single Metahuman character has ever been created using Metahuman Creator in Unreal 5.6, then the shared body post anim blueprint and head post anim blueprint must already exist within the project. In short, although the project may be running in Unreal 5.6, if you've never once used Metahuman Creator within this project, those animation blueprint templates won't exist yet. Even if you're using an upgraded version of Epic Games' older Metahuman project, or your own legacy project that you've converted to Unreal 5.6 or higher, the same issue can occur, because Metahuman Creator has never been used in those projects either. The fix is simple. Open the plugin settings and enable all plugins related to Metahuman, including Metahuman Creator, Metahuman for Maya, and any other Metahuman-related plugins listed. Just enable everything shown there. But before restarting, open your Epic Games launcher, go to your installed Unreal Engine version, and click Options. In the options, make sure that Metahuman Creator core data is checked and installed. This is extremely important because you're now moving forward with the fully updated Metahuman pipeline. Once everything is installed and the engine restarts, go to the content browser and click the gear icon. Enable both plugin content and engine content. This will make the engine folder appear in the content browser. Now go into the plugins folder, scroll down, and you should find a folder named Metahuman Creator. This is the core folder for the Metahuman Creator system. Inside it, go to the Optional folder, then into the Preset folder. There, you'll see all the presets used by Metahuman Creator in Unreal 5.6. I'll open the preset named Ada and then export it into the Engine Content folder. From now on, I'll add MH to the end of all character names exported from Metahuman Creator to avoid confusion. A message appears saying that the current character hasn't been rigged yet. So I'll go ahead and click Create Full Rig to automatically rig the character. Depending on your setup, you may need to log in to your Epic Games account at this point. Next, to proceed with export, I'll download the textures. Once that's done, go to the Assembler tab. You'll see the Assemble button become active, highlighted in green. The system will warn me about all the assets that might be affected by this change, but I'll click Yes because I need to fully upgrade everything to the latest format anyway. Of course, this will likely cause issues with older metahumans like Ada or Taro, created under the legacy pipeline. But don't follow this step blindly. Only do the same if your project matches my situation. In my case, I'm okay with replacing the existing skeleton structure completely. But from now on, the skeleton inside the Metahuman Common folder will be the new style Metahuman Skeleton. Once the export is complete, don't modify the preset. You'll see a new folder named Ada MH, confirming that the export was successful. I'll go ahead and save this entire folder. If you check inside the Common folder, you'll notice new animation blueprint assets have been added. I'll save this entire Common folder as well. Now let's briefly open the body skeletal mesh of Ada MH. You'll see that it has a post-Anim blueprint assigned to it. This is exactly the shared body post-Anim blueprint we've been looking for. Now let's go back and click the Check Template button again. This time it correctly detects the Metahuman Common template and displays the appropriate confirmation. The head DNA path and the body DNA path in the designated fields. Then, select your character's blueprint and click the button. This will load both the body and head. Next, click the Auto Settings button. At this point, it looks like everything is finally set up. However, with this tool, there's a high chance that the DNA might not have been properly loaded. Open the skeletal mesh, and you'll see that the post-Anim blueprint has been applied. But take note, this is not the one generated by Metahuman AutoSet Newest. It's actually the shared post-Anim blueprint used in Metahuman Common, specifically this post-Anim blueprint right here. Now, if you check the asset user data, you'll see that some DNA data has been embedded. But if you follow it all the way through and carefully check the specified path, you'll notice something odd. Even though we input the head DNA, the head skeletal mesh is showing the body DNA file instead. This happens because Unreal 5.6's DNA embedding system has some bugs when used via Python. Sometimes it embeds correctly, and other times it doesn't. So, after using Metahuman AutoSet, you must manually reinsert the correct DNA file into each skeletal mesh. Now that we've checked it again, the head DNA is correctly applied. Let me emphasize this one more time because it's so important. After using this tool, always manually embed the correct DNA file into each skeletal mesh. And make sure the skeletal mesh matches the DNA file you're applying. Once you've applied the post-Anim blueprints, toggle the Enabled setting on and off to check if the body mesh pops or shifts. If the body only behaves strangely when the blueprint is enabled, it means the base pose wasn't correctly saved into the body DNA. Anyway, now that setup is complete, let's give it a quick test. I'll create a level sequence and bring in our character BP. Let's position the character somewhere well lit so the lighting hits nicely. At the top, you'll see an icon related to gimbal controls. Set that to local space for easier movement. Yes, this looks great. It appears just as we designed it in Maya. There's no gap between the head and body, and everything is aligned properly. Even the facial expressions are functioning correctly. At first glance, it might not seem that different from the older versions, but here's the key difference. This MetaHuman is running on the latest DNA format, MH6. Now, what do you think that means? That's right, compatibility with Metahuman Creator. It means you can now import characters you previously designed, along with their DNA files, directly into Metahuman Creator. In the next session, I'll give you a detailed walkthrough on how to actually do that. Thanks so much for sticking with it until the end. Thank you for watching.